This video is for Nova Online Math 161. Today we're looking at the final exam review topic of exponential decay application. The function a equals a sub 0 times e to the negative 0.0054x models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. Suppose 1,000 pounds of the material are initially placed in the vault. The first part is asking us to find how many pounds will be left after 155 years. So let's find the A value after 155 years. So the initial value, A sub 0, they told us that is 1,000 pounds. So we're going to start with 1,000 multiplied by e to the negative 0.0054. But remember they said x stand for what? X stand for the number of years since the material was put into the vault, right? Now, what was that number for us for part A? 155 years. So, you are going to put 155 as a number we're multiplying to that decimal rate, okay? Now, we need our calculator to evaluate this. So watch, I'm going to type into this Desmo scientific calculator that I have. 1,000 times e raised to the negative 0.0054 times 155. Now, 155 years later, we're going to have about 400 and, oh, hold on. All right, we're going to have 433 pounds of this material. So we got the answer for the first part. Now let's see what else we have to do for this exam problem. Part B is asking us to find how much time will need to pass for only 60 pounds to remain. Now, I'm going to copy this equation down. And we're going to use this equation, plug in some of the things we know, and solve it backward, okay? When they said only 60 pounds to remain, they're talking about the ending amount. Yeah, that's how much we will have in the future, okay? So put that 60 as the A value on the left side of the equal sign, okay? Now, A sub 0, oh, they never said any other number, right? Remember they said they started with 1,000 pounds of this? So I'm going to just keep on using that 1,000 pounds. And then we'll copy this exponential term down exactly the same. E to the negative 0.0054x. So we're solving for x. And x stand for the number of years. Okay, now let me read that exact part. X is the number of years since the material was put into the vault. So that's what we're trying to find over here. Will it take 1,000 years? 500 years? Let's solve for that x, okay? So to solve this, divide both sides by 1,000. So we start by dividing both sides by 1,000. Let me type in 60 divided by 1,000 to get a decimal approximation. I don't want to round it in the middle of a problem, but I feel like that's going to be an exact decimal. So I'm going to use that. Instead of keep on writing 60 over 1,000 or 6 over 100, I'm just going to write it as 0.06 on the left-hand side, okay? So 0.06. 0.06 equals, now the 1,000's gone. Bye-bye. But I do now still have e to the negative 0.0054x. Now, how do you get rid of, how do you bring down this exponent down and at the same time get rid of that e, okay? Remember, we can take natural log of both sides. So if you take natural log of the left side, you get natural log of 0.06. But you know what will happen when you take natural log of the right side? Yeah, I'll write it, okay? You're going to get natural log of e. Let me just duplicate this real quick. Natural log of e to the negative 0.0054x. Now, what will happen? This exponent of negative 0.0054x will jump down to the front. It will go out to the front, okay? So now we have natural log of 0.06 equals negative 0.0054x. Guys, I was about to write the next part down. Look at the next part. ln e. What is natural log of e? Natural log of e is just 1, okay? So that green underlined part right there, you guys, that's gonna just become 1, okay? So when you multiply something by 1, will it really do any kind of change? Not really. So I'm not saying they cancel out, but the effect kind of is gone now, right? So I'm just gonna cross out ln e, okay? Because that's just gonna give us 1. And multiplying this decimal by 1 doesn't change anything. Now, final step. We're going to divide both sides by that decimal, negative 0.0054. But divide both sides by that, 0.0054. So let's get the answer, okay? The exact form is going to be natural log of 0.06 divided by negative 0.0054, but we want this to be like how many years, right? So let's go ahead and type this into our calculator to get a decimal approximation, okay? So I'm doing fraction that has natural log of 0.06, and in the denominator, let's carefully type in negative 0.0054. Ooh, it's going to take how many years? 521 years for this radioactive substance to become only 60 pounds if it had originally 1,000 pounds to begin with, okay? So this was an application of exponential decay. Notice the first part was easy. We just had to plug in the given number into the function. But the second part was definitely a little more. We had to set up an equation and solve the exponential equation by taking natural log of both sides.